Hello viewers, I am Aditya and today we will know why are computers getting smaller and smaller? How could anything shrink in size while growing in power? What will be the next successor of today's supercomputer? And is my brain or your brain more powerful than a computer or supercomputer? In this video, we will see answers of all these topics. If you are new to my channel, please don't forget to like, share and subscribe the channel and also press the bell icon so you get notifications of my videos all across the topics. So let's start the video. Computers in 1950s were the size of a house. Literally, today your vastly more powerful smartphone fits in your jeans pocket. How could anything shrink in size while growing in power? The big breakthrough was the invention of transistor, a tiny device that controls electronic signals. Like a nerve cell in a human brain, a transistor works with the other transistors to store and process information in computing devices and other gadgets. Transistors were installed on silicon microchips, which replaced much larger vacuum tubes in 1950s. Many consider the transistor the greatest invention of 20th century. In 1965, Gordon E. Murray, co-founder of the high-tech Intel Corporation, predicted that the number of transistors that could fit on a microchip would double every 2 years. Known as Murray's Law, his prediction held true. In 1971, computer makers could fit only about 4,000 transistors on a chip. By 2011, they could cram in over 2.5 million. So, today's engineers are searching for a transistor's successor. Is supercomputer successor a hypercomputer or a quantum computer? First, we have to see the history of the computers. The Antikythera Mechanism, designed in 100 BC. Input method, knob and crank. Size, approx 1 foot into 6 inches into 4 inches. Recovered from a shipwreck of the Greek island of Antikythera in 1900, this toaster-sized device may have been the world's first analog or mechanical computer. Archaeologists believe the Greeks used it 2000 years ago to calculate the courses of constellations and predict eclipses. Smaller than an modern PC, the Antikythera Mechanism contained at least 30 bronze gears and was remarkably efficient for its size. It even had an instruction manual inscribed on copper plates. Difference engine, designed in 1837. Input method, punched cards. Size, about as big as your living room. Devised but never actually built by English mathematician Charles Babbage, this massive contraption relied on metal tumblers and cranks rather than electricity and transistors. Yet, it had all the components of a modern computer: a memory for storing numbers, a central processing unit for calculating math problems, an input device punched card for entering information, and an output in the form of printer and a bell, which would make the differentiator the first computer with sound effects. Eniac, designed in 1943. Input method, plugs and switches. Size, house size. Eniac, the electronic numerical integrator and computer, was the world's first general-purpose electronic computer. Although it took days to program, Eniac could perform thousands of calculations in a second. That power required some serious hardware. The Eniac was large enough to live in, weighed more than 30 tons, and took up space of a typical single-family house. Built before smaller and more efficient transistors, Eniac relied on more than 17,000 soda can-sized vacuum tubes that often malfunctioned when the massive machine was powered up. Eniac's operator came up with a simple solution for that. The computer never continuously for more than 7 years. It was even rumored falsely that Eniac's massive power needs were responsible for occasional power outages in the nearby city of Philadelphia, Pennsylvania, USA. Apple II, designed in 1976. Input method, keyboard and cassette drive. Size, smaller than a suitcase. The first successful mass-produced microcomputer, the Apple II offered simplicity, the ability to upgrade and style for the time at least, in a sleek beige box that hooked to your TV. Although primitive by today's standards, the Apple II sold in millions and ushered in the era of personal computing. It was also one of the first personal computing that could play a decent home version of arcade games. Ibm Simon. Input method, touchscreen. Size, brick size. Considered the world's first smartphone, this touchscreen control device combined the features of a computer, email client, calculator, calendar, appointment scheduler with a cell phone, which transmits radio signal to the nearest cell antenna to communicate with other cell phone users, paving the way for today's iPhones and tablets. It was the first phone that did other things and one of the first computers that could fit in your pocket. Google Glass, designed in 2011. Input method, voice commands and eye movement. Size, fits on pair of eyeglasses. The first in a new wave of wearable computers, Google Glass combines a tiny computer with a pair of eyeglasses and that works like a smartphone for your eyeballs. The eyepiece directly displays all sorts of handy data, from text messages to directions. Although Google Glass users run the risk of stumbling into traffic as they browse their email. Critics complain that the device's built-in camera represents an invasion of privacy. Oculus Rift, designed in 2014. Input method, joypad, gesture commands. Size, as large as pair of snow goggles. The long-awaited promise of exploring virtual reality comes true in the headset decked out with high-definition displays for each eyeball, creating a three-dimensional wraparound view that shifts with your hand movement without any noticeable lag. It might be the closest you'll get to experience Harry Potter's reality shifting room of requirements in real time, as long as you don't get upchuck from motion sickness. Quantum computer, to be designed. Input method, unknown, possibly telepathy. Size, smaller than your fist. With transistors and microchip shrinking to their dinkiest point, computer engineers are thinking small to create the next big thing. By using subatomic particles instead of transistors, the quantum computer of 2020 could pack 1,000 times more processing power than today's computer in a case the size of a coffee cup. So, is my brain with two former champions on TV quiz show Geology? Processing power, human brain, 2.2 billion megaflops. Watson computer, 80 million megaflops. Memory capacity, human brain, 2560 terabytes. Watson supercomputer, 16 terabyte. Power consumption, human brain, 20 watts. Watson supercomputer, 2 lakh watts. The winner, your brain. Watson may have rigged two humans in a game of trivia, but it thousands of processor cores and dozens of servers still can't come close to replicating the complexity and power of the neurons in your login. The human brain can achieve more than a trillion neural connections, and it has enough memory to hold 300 million hours of TV shows. Still, computer scientists suspect they are able to build a computer that replicates the brain abilities.